Okay, yeah, so now we are doing question 3, which is the vertical projectile motions. So let me read you the statement. So the statement says, this is also from 2022, né? It's still November 2022. So if you go to the internet and check for this paper, you will get it. So now we are doing question 3. So the statement says a ball is thrown. So that's a very important word. Thrown. The ball is thrown. So that means there is an initial velocity. So it's thrown vertically upwards from the top of a building of a height 25 meter. So the height is 25 meter. This is the height of a building, and then the velocity of 12 meters per second. So the initial velocity is 12 meters per second. The height of the building is 25. So I want you to underline this with 25 meters per second is the initial velocity. Here is it. So the initial velocity of a building is 12. And then on its way down, the ball passes a door which has a height of 1,9 meters. So here is a door. So the height of this door is 1,9. The height of a building, is 25 meters. And then strikes the ground as shown in the diagram below. Ignore the effects of air friction. So before we go to the questions, let me draw or redraw this diagram. There are things that I want us to unpack from this diagram. So let me draw again here. So let's say this is the building. Okay. So this is the building with the height. So this is the ground. Here is the ground. Okay. So this is your ground there. And then some point here, let me say at this point, there is a door here. There is a door at this point. So let me just draw the door. Okay, so let us look at the projection of the ball. I want us to write every value that we know. So the ball is coming from this point. This is the ball, and it went up. It went up and turn at some point, and it goes down up until it reaches the ground. So I'm going to say this is section 1. So from the initial velocity, which was 12 meters per second, the ball went up to reach the final velocity, which was 0. So there at the top, this is section 1. So I call it section 1. So the ball is moving up. The ball is moving up. That's section 1. This is the initial velocity. That's the final velocity. But we don't know how long it took for the time. We do know this one. I will explain what is the acceleration there. We also don't know what was the maximum displacement there. Okay, so that is section 1. So the ball went up. So on this other side, let's say we have section 2. On section 2, the ball is going down. So it started here. So when the ball was going down, I'll call this the initial velocity, which is 0 because of it. reached the maximum velocity of 0 when it went up, so it's gonna start at that 0 to go down. But when the ball reaches this point, which is equal to this point, so it was going up, at this point was positive. Now when the ball is going down, this point is going to be the same value but in opposite direction. So when the ball is going up, in my case, let's take the direction up is positive. If up is positive, that means down is negative. So you must keep this in mind as a direction. So when the ball is going up, the initial velocity is positive 12, the final velocity is also 0, which is positive. But when the ball is going down, so imagine this is negative, the final velocity at this point on section 2 is negative. We don't know the time it takes, we don't know the displacement, we do know g. I will explain g later on. So let's call this section number 3. So we have another section here, so I call this section 3. The ball is still going down. So this point on section 3, this point, the velocity is still negative 12. It's the same point. But at this point, okay, let's call this initial velocity. Let's call this one initial velocity so that I don't confuse you. So let's call this initial velocity, it's still 12. So at this point now, the final velocity at this point we don't know, but we know it is negative. The time here we don't know, delta g or delta y we don't know, and g, I will explain g later on. And then we have the fourth one, the fourth section, which is this one. So I'll call this section 4, which is from here now to the ground. So this is the direction of the ball to the ground. So the velocity at this point we don't know, the final velocity on the ground we don't know, but we know it's negative. Delta y we know because they told us the door is 1,9 meters, so we know delta y here is negative 1,9 meters. And then g I will explain later on. So we have section 1, section 2, section 3, section 4. So every time you are given a problem like this, you need to divide all your section into 4 sections so that you can be clear what's going on. So let's talk about g. If you take up is positive, g is equals to negative 9,8 meters per second square always. So that means section 1, when the ball is going up, g is negative 9,8. When the ball is going down, g is negative 9,8 meters per second square. Even here, g is negative 9,8 meters per second square. Even here, g is negative 9,8 meters per second square. So g is always negative 9,8 when you take up as positive. G is always 9,8 throughout the projection of the ball. G is always negative 9,8. But let's look at the velocity and displacement. So when the ball is going up, the velocity is positive, displacement will also be positive. But when the ball is going down, the velocity there is negative, the displacement there is negative, the final velocity there is negative. On section 3, when the ball is going down, the velocity starts as negative. Even at this point, it is still negative. So even at this point, it is still negative. and G is also negative. We don't know at the moment, but we can find G. Remember, the height of the building is 25 meters and the door is 1,9. So we can find this part by saying 25 minus 1,9. 25 minus 1,9. So 25 minus 1,9. So it's 23,1. So that means this section here is 23,1 meters. So section 3, the displacement here is 23,1 meters. It's negative because of the ball is going down, and when the ball is going down, all your vectors are negative. So we don't know the time, we don't know the final velocity. Now here at section 4, we don't know this velocity, we don't know that velocity. We do know delta y is 1,9, g is negative 9,8. Why negative? Because when the ball is going down, velocity and displacement are negative. When the ball is going up, velocity and displacement are positive. So this is the picture, this is what we have. Now let us write our formulas. Let's say formula number 1, v final square is equals to v initial square plus 2a delta y. Formula number 2, v final is equals to v initial plus a delta t. Formula number 3, delta x is equals to v initial plus v final all over 2 multiply by delta t. And then the last formula, delta x is equals to v initial times delta t plus half a delta t squared. So we have these 4 formulas. Now let's now try to get to our questions and see what they are asking us. So you have 3.1 says define the term free fall. Define the term free fall. So we do know what is free fall. 3.1, we know that free fall is a motion of the object where the only force acting on that object, the only force acting on that object is the force of gravity or the gravitational force. Is the force of gravity, is the force of gravity or the gravitational force. So it's the force of gravity. So there are there's 2 marks here. So the first mark that you will get is the mark of stating only, the only force. That they will give you 1 mark, and then you state that force, it is the force of gravity, they will give you another mark. So that's how we get it at 2 marks for 3.1. Then 3.2, calculate the time taken for the ball to reach its maximum height. Calculate the time taken for the ball to reach its maximum height. So they want now this time. They want now this time. The time the ball takes to reach the maximum height. The time from here going up to reach the maximum height. We want this time. So we do have initial velocity, we do have final velocity, we do have g. So we need a formula that has v initial, v final, and g. So let's check. We can't use the first one because there's no time. We Now for this one, we can use this one because we do have v final, we do have v initial, we do have g, so we can use this one. We can't use this one because we don't have delta y, we don't have this one, so the only formula we can use is that one to find the time taken for the ball to reach the maximum height. So that is 3.2.1. So we say 3.2.1 v final is equals to v initial plus a delta t. So what is v final? V final is 0, v initial is 12. So v final is 0, v initial is positive 12. Then we said g is always negative 9,8, so we want delta t. So in this case, this is 0. We can take the 12 and put it that side. It's going to be negative 12. 9,8 times delta t is negative 9,8 delta t. So let's divide by negative 9,8, divide by negative 9,8. So we can say delta t is equals to, we have 12 divided by 9,8. 12 divided by 9,8. So the answer is 1,22. So the time is 1,22 seconds. So we do know this time. This time is 1,22. The time is 1,22 seconds. 1,22 seconds. Yeah, so that was number 3.2.1. So I think it's a 3-mark question. Yeah, the maximum time taken for the ball to, or the time taken for the ball to reach the maximum height is 3 marks. So always they will give you 1 mark for the formula for substituting that initial velocity, 1 mark. For the final answer with the correct units, 1 mark. So that's how you get your 3 marks. Here that was your 2 marks. So let us look at the following question. Now calculate the velocity with which the ball strikes the ground. The velocity with which the ball strikes the ground. So now we want this velocity here. The velocity with which the ball strikes the ground. We want that velocity. So the ball started here and then it struck the ground. So we want to know what is this velocity, and that velocity is negative. So let's check now what we have. Let's look at this at this section where the ball was going down. So from this point, from here down to here, there's a lot of information that we have here. From this point, we know the velocity here. We said it's negative 12 because it started at positive 12. This is the same point. So we do know the velocity is negative 12 because the ball is going down. And then what else do we know? We do know delta y because delta y is at this point 23,1 and here 1,9, which is 25. So we know delta y at this point is 25 meters. We know g always is negative 9,8. So we want now the final velocity on the ground, which is negative. So we have initial velocity, we want final velocity. We have delta y, we have g. So let's look for the formula that has these four things: the initial velocity, the final velocity, delta y, and g. So I think the first one will work. We want v final, we do have v initial, we do have g, we do have y. So we can use the first formula. So let's use that one. 3.2.2. So for 3.2.2, 3.2.2, v final square is equals to v initial square plus 2a delta y. So we are looking for v final. We said the v initial is negative 12 square plus 2g is negative 9,8, delta y is negative 25. So everything here is negative. V initial is negative 12, delta y, because the ball is going down, is also negative. G is always negative 9,8 because we took up as positive. This final velocity will also be negative. So let us check now. So v final square is equals to, then 12 squared is 144 now. So it's a positive 144. Then 2 times 9,8 times 25, 2 times 9,8 times 25 is 490, which is negative. Now let us add these two. So we have v final is equals to, so we have 144 minus okay, sorry, I think this is going to be positive because it's 2 times negative and negative is positive. So 144 plus 490, 144 plus 490 is 634. So this one is 634. Then you take the square root of 634, the square root of 634, and then we get the answer to be 25,18. The answer is 25,18 meters per second. Then it is going down. So that means this value is negative because of it's going down. Okay, so this is the answer for the final velocity on the ground. The final velocity on the ground is negative 25,18 meters per second. So yeah, we're done with that one. Let's look at the following. 3.2.3. the time it took for the ball to move from the top of the door to the ground. From the top of the door to the ground. So now we want the time it takes for the ball to move from the top of the door to the ground. So we want the time it takes from here, from the top of the door to the ground, to here. So what do we have here? So we do have the final velocity as 25,18. We do have g as 9,8. We have delta y is negative 1,9. We want now delta t. Or we don't have this velocity there. So we want delta t. Okay, let's check on the formulas if there's a formula we can use for the time. So the first formula will need that initial velocity. We don't have this initial velocity, so we can't use this one. We can't also use this one because it needs the initial velocity. Let's look at this one. It also needs the initial velocity. So that means we need to get that initial velocity there, because all our formulas need that initial velocity to find the time. So the first calculation is to find this initial velocity. So we can use the first formula because we do have v final, we do have g, we do have delta y. Let's find the v initial. So for 3 comma, this is 3 comma 3 comma 2 comma 3. So 3 comma 2 comma 3. So we're going to say v final square is equal to v initial square plus 2a delta y. So we say the final velocity we do have. What is the final velocity? The final velocity here is negative 25,18. That is the final velocity we do have is negative. It's negative 25,18 square equals to, we want the v initial square plus 2g is always 9,8. Then delta y, the height of the door is 1,9. The height of the door, but we're gonna say negative 1,9 because the ball is going down. Even this one, it is also negative. So everything here is negative. Then 25,18 square. Let's find 25,18 squared. That is 634,02. That is 634,02, 0.0324, 0.0324. We don't round, we only round at the last answer. So negative squared is going to be positive squared. Then we have now negative times a negative, the answer is going to be positive. So let's multiply 2 times 9,8 times 1,9. So we have 2 times 9,8 times 1,9. So we have 37,24. 37,24. Now we have the like terms now. This and that is a like term. So let's take this one to that side. So on the other side we have v initial square. On the other side we have 634,0324 minus 37,24. And then let us find that answer. 634, we have 634,0324. We subtract 37,24, and then we have 596. We have 596,7924. Then we must find the square root now of this one. The square root of 596, that. So we want the square root now of 596,7924. So it's 24,43. 24,43 meters per second is downwards. So this velocity, this initial velocity, this one that we did not know, now we know it's negative 24, it's 24,43. It's 24,43 meters per second square, and it is negative also. So we do have now the initial velocity. Let's go back to that question now. calculate the time taken by the ball to move from the top of the door to the ground. Now we can find the time now. We can find now this time, the time here, because we do have now the initial, we do have delta y, we do have g, we do have v final. So we can use any formula that we want. We can use this formula, we can use this formula, we can use that formula. So let's use formula number 2. Formula number 2. So it's the same calculation. So v final is equals to v initial plus a delta t. Now what is the final velocity on the ground? We said the final velocity is 25,18. Is negative 25,18. The initial velocity is the one we just calculated, negative 24,43. Then g is always 9,8 times delta t. So we take this one to that other side. So it's negative 25,18 plus 24,43 equals to 9,8 delta t. So let's find that one. So we have negative 25,18 plus 24,43. So the answer is negative 0,75. We have negative 0,75. On the other side we have negative 9,8 delta t. So we divide by negative 9,8, we divide by negative 9,8. So delta t becomes 0,75 divided by 9,8. So the final answer is 0,077. 0,077 seconds. That is the answer. Remember, negative divided by negative is positive. So this is the time it takes to move from here to there. The time there is 0,077. The time is 0,077 seconds. Now let's move to question 3. Now 3.3, they say draw. So now we are moving to the graphs. Draw a velocity versus time graph for the motion of the ball from the moment the ball is thrown up until it strikes the ground. Use the ground as zero reference. Indicate the velocity with which the ball was thrown up, the time taken by the ball to reach the maximum height, and the velocity with which the ball strikes the ground. So we need to indicate this, and then we need to indicate the time here. We need to indicate the velocity here. We all have this. So let's draw the graph now. So that is 3.3. So when you draw the graph must always have the axis, y-axis, and the x-axis. So this would be my x-axis. Okay, x-axis. Okay, so on my y-axis, remember this is the velocity versus time. You must always write your heading velocity versus time. So on your y-axis you have your v in meters per second. You must write that one. Then on your x-axis we have t in seconds. So these are the first things that you do, and then you need now to get your coordinates, the y coordinate and the x coordinate. In other words, the velocity and the time. So when the ball started to move at this point, what was the velocity, and what was the time? When the ball reached that point, what was the velocity, what was the time? When the ball comes down and reaches this point, what is v and what is time? When the ball reaches this point, what is v and what is time? So we want x and y, or y and x, y and x, y and x, y and x. That's how you plot your graphs. So you need 4 coordinates, 4 points. Point number 1, when it started, what was v, what was time? Point number 2, when it reaches the top, what was v, what was time? Then when it comes down to the same point it started but in opposite direction, what was v, what was time? The last point is when it strikes the ground, what was v, what was time? So we want to know these 4 points. So let's look at point number 1. We do know v was 12 and the time when it started was 0. It started at 0 seconds and v was 12. So we know y, which is velocity, it was, let me say my y is here, my y was 12 and my t was 0. So the first point here is 12 and 0. That's my first point. The velocity is 12 and the time is 0. Let's do it like this. So we have v and we have t. We have v and t. So this is the first point, second point, third point, and fourth point. So initially my v was 12 and the time was 0. So we have the first point, the v was 12, time was 0. It started 0 time, and then it goes up. Now it reaches this point. What is v at that point? What is the velocity at that point? We know the velocity is 0. What's the time at this point? The time is 1,22. So the second point, now we know the final velocity was 0 but the time was 1,22. Let's find the third point. So the third point is when the ball now is going down to this point. What is velocity at this point? It's negative 12,22. Sorry, it's negative 12. It's negative 12. That is the velocity. So we know v is negative 12. But what is the time? So the time at this point, if it takes 1,22 to go up, it's gonna take 1,22 to go down. So it's like we have 1,22 times 2. So the time is 2,44. This time is 2,44 seconds. So because it takes 1,22 to go up, it takes 1,22 to go down. So that's 2,44. So the time is 2,44. 2,44. The last point now on the ground. So on the ground, what is the v on the ground? V on the ground is negative 25,18. Negative 25,18. Negative 25,18. Then what is the time on the ground? So the time on the ground when the ball strikes, remember the time is continuous. So we have the time when it started plus another time 1,22 plus this time plus this time. So we have 4 times here. We don't have this time, we didn't calculate that time, so I would assume it's 2,44. so the time is like the time on the ground. The time, you don't have to calculate this, but I just want to check something. So just want to see if I have, okay, I just want to choose another pen. I want this one. So the time on the ground, let's say t is equals to, it started at 1,22 plus 1,22 plus, now we don't know this time, and I'm not going to calculate that time, I don't know what is it, plus that time plus the last time, which is 0,77. So when you add all your times, it's like 1,22 plus 1,22 is 2,44 plus another time that we don't know plus that time. So we don't know what that time is. The question says sketch, so you don't have to stress yourself. So we don't know what is this time, but don't worry, it's going to be more than 2,44. So when you draw now your graph, it's like this is x, this is y. So the first point now on your y axis, this is like your x axis. So the y is 12 and the x is 0. So this is x is 0 and the y is 12. So this is the first point. So we're done with that one. Let's look at the second coordinates. When y is 0, x is 1,22. When v is 0, t is 1,22. So when the velocity is 0, x is 1,22. So this is 1,22. So it's the second point. V is 0, then x is, time is 1,22. And then we're done with that one. Let's take the other one. When v or y is negative now 12. So negative 12 would be somewhere here. So it's negative 12. So that is negative 12. So let me draw the graph going, extend it downwards a little bit. So I'm going to extend the graph down. So we have y is negative 12. We want now the time at 2,44. This is 2,44. 2,44. So when y is negative 12, x is negative, is 2,44, which is the point, like let's check, is the point here. So it is the point here. That's point number 3. Then the last point is when y is negative 25,18. When y is negative 25,18, then x will be somewhere there. We don't know the x, we don't know this time, but you can calculate if you want, but you don't have to. It's going to waste your time. Then there's going to be another point when y is negative 25,18, then there will be a point there. And then these are the 4 points that you have. Then you take your ruler, then you join your points. Now mine is not going to be accurate, It's not going to be accurate, but I hope you can get the point. Join. Okay. This writing pad of mine is not going to help me much, but let me try. You join, then the last one you join. Okay, but the graph must be a straight line. It must be a straight line graph, not a curve, so you need to make sure that when you draw it, it must be a straight line graph. But you can see what I was trying to do, so I hope you can get a straight line graph when you draw your graph. So yeah, it's a straight line from there down straight to there. So that's how you get your 4 marks. Is it a 4 marks? I think it was a 4 marks question, or it was a 3 marks. So 1 mark is for the velocity, initial time taken to reach the maximum height, velocity when it strikes the ground. So they will give you 3 marks for the graph. So let me give you these marks so that you can see. So the first mark, according to the instruction, they said they will give you 1 mark for that one, 1 mark there, 1 mark there. So it's a 3 marks. So there's no mark for this, there is no mark for that, there is no mark for this. So you must show this and show this and show that one. That's how you get your velocity versus time graph. Okay, then I will do now the momentum in the next video. Sure.